Building your brand and growing your business online. July 1st, 2025. A barely visible dim pixel glides across the sky, which is picked up by the Atlas telescopes in Hawaii and South Africa. Its motion is strange, its speed is alarming, and its trajectory is sharply hyperbolic. Astronomers run the orbital calculations, and one thing becomes clear. The object is interstellar, the third of its kind after Comet 2I Borisov in 2019 and Oumuamua in 2017. It's named 3I Atlas, and early observations suggest that it may be an active comet. From images, we also saw that this object is active, which means that around the nucleus there is some coma, which is an indication that this object is in fact a comet. That sets it apart from Oumuamua, which showed no signs of outgassing at all. In fact, Atlas appears to be more like Borisov, a comet in behavior. And that raises an unsettling question. If Atlas and Borisov follow a familiar pattern, then why did Oumuamua break it? How did it just fly past us without anyone noticing until it was already leaving? The detection of 3I Atlas makes Oumuamua seem even more alien. Music. October 19, 2017. Pan-STARRS 1 is scanning the night sky. At 1:22 Hawaiian Standard Time, a sliver of pixels dashes across the frame, noticeably faster than the usual background clutter. A few hours later, at a workstation in the University of Hawaii's data center, astronomer Robert Werrick scans those images and notices a streak racing faster than a space rock should. The object is clocking an inbound speed of 26 km per second and with an eccentricity of 1.20. Its path is an escape ramp, a trajectory that will swing past the sun once, then fling back into space, never to loop around again. In the next 24 hours, the object receives its first name, C2017U1, on the assumption that it must be an odd comet. But the very next day, follow-up observations show no cometary tail. So the C is struck out and it becomes a 2017U1. However, even the asteroid label doesn't hold for long. So the International Astronomical Union coins an entirely new class, I for interstellar. And the visitor is officially named 1I Oumuamua, Hawaiian for Scout. Astronomers realize that the object is moving away fast, fading beyond 24th magnitude, and they have barely 40 days to measure and find out what it is before its trail goes dark. The visitor was speeding in at 26 km per second, coming from the general direction of the star Vega in the constellation Lyra, the same patch of sky our own solar system is drifting toward. At its closest approach to the Sun, it dipped well inside Mercury's orbit, just 38 million kilometers away, then swung outward on a mirrored curve. And with no further nudges, it is headed toward Pegasus, vanishing out of sight for good. Now backtracking that path through stellar maps is like trying to trace a single raindrop to the cloud. After tens or hundreds of millions of years of drift, gentle tugs from passing stars and galactic tides had blurred the trail. It is possible that in the turbulent youth of a distant planetary system, migrating giant planets hurled the fragment into interstellar space where it drifted for ages until by sheer luck it crossed our neighborhood in 2017. Or is it? Photometry collected by multiple observatories around the world showed that every 7.3 hours, the object's light surged almost tenfold, then faded just as sharply. Such wild swings point to a body that's either extra long or extra flat and tumbling end over end like a cigar, or perhaps a saucer seen edge on because no telescope has ever resolved the object itself. Even to this day, both shapes remain on the table. And then came the biggest shocker. When the European Space Agency traced its path past one astronomical unit, Oumuamua showed to have gotten a sudden acceleration. The nudge is small, about 5/millionths of a meter s². Yet, it shows up clearly in every dataset. That level of acceleration would normally point to comet-style jets, but any outgassing should leave a visible dust or gas cloud. Instead, every telescope saw a perfectly clean trail. No dust, no vapor. Solar radiation pressure at that distance is far too weak to produce such a push unless the object has an extraordinarily high surface area to mass ratio, as if it were an impossibly thin sheet. No natural process can create something hundreds of meters across, yet thinner than a sheet of paper. So, what were we looking at? Before that, let's quickly hear from today's sponsor, which offers the best tools for easy website design. With their AI-backed design intelligence, creating your unique digital identity is fun, effortless, and quick. Their website design system called Fluid Engine lets you customize every design detail with this extremely helpful drag-and-drop technology. Also has built-in analytics so that you can easily track who's coming across your new page. To get to the bottom of it, NASA turned its Spitzer space telescope to lock its infrared eye on Oumuamua for 30 hours. Spitzer can detect the warm dust of ordinary comets a few kilometers across, even beyond 2 astronomical units. But on Oumuamua, it found nothing. Just silence. No thermal glow at all. Instead, Spitzer data added even more to the mystery. Its observations revealed that Oumuamua's surface is at least 10 times more reflective than the carbon-rich crust of typical comets. So, could its surface be metallic? In late 2018, Harvard's AVI Lab and his team ran the numbers in a paper for the astrophysical journal Letters. Since no known natural process makes something like this, Lab proposed a startling alternative. Perhaps we were looking at artificial light sail technology, a derelict probe or piece of spacecraft sent from another star. Their bold hypothesis lit up headlines around the world. Some hailed it as open-minded science. Others dismissed it as sensational. Meanwhile, 2 scientists stepped in with a more grounded alternative to Lab's proposal. Daryl Seligman and Jennifer Bergner pointed out that when water ice sits in the cold depths of space just a few degrees above absolute zero, cosmic rays can crack hydrogen molecules free and trap them in tiny pockets. Over millions of years, an ice chunk becomes a hidden hydrogen reservoir. As it warms above about 40 Kelvin during a close pass by the sun, that trapped gas seeps out like an invisible jet, nudging the body forward, yet leaving no dust, no carbon dioxide, and no heat signature for our infrared telescopes to catch. They coined these stealthy objects dark comets. This theory accounts for the unexpected push and the spotless trail, offering a natural explanation rather than artificial. Since their study, astronomers have uncovered a growing family of these stealthy bodies within our solar system. All share the hallmark of dark comets: measurable outward jet forces with no dust or gas detected, implying invisible volatile-driven thrust. So yes, these objects have gone from a hypothesis to a recognized class of small bodies in our solar system. However, AVI Lab has remained publicly unconvinced by the dark comet idea. In a series of essays and follow-up papers, he's argued that the hydrogen ice model miscalculates how the surface cools as hydrogen escapes and that the required outgassing would still leave detectable effects. In Oumuamua's case, he continues to press for a radiation pressure-driven light sail instead. So, how do we settle this debate? Enter Project Lyra, a blueprint sketched by the Interstellar Probe Working Group. Their vision is to launch a small probe around 2028 aboard a Falcon Heavy or Starship, sling it past Jupiter for a gravity boost, then dip it close to the Sun for a no-birth burn, harnessing solar gravity like a slingshot to send it on a 20 to 25 astronomical units per year trajectory. In theory, that craft could catch up, but not until the 2050s, when Oumuamua will be 200 to 250 astronomical units away and fainter than magnitude 35. Pulling off such a mission means mastering heat shields to survive the solar dive and propulsion systems more powerful than anything we've ever flown. It's a long shot, literally. Or there is another way. Rather than chase a fading target, many researchers prefer to ambush the next visitor. And this time, we just might have. On July 1, 2025, the Minor Planet Center listed a new object, now officially named 3I Atlas. While Oumuamua defied all categories: no tail, no visible gas, no thermal emission, Atlas appears more familiar. And that's exactly what makes it so important. By comparing these two cosmic outliers, astronomers now have a real chance to separate what's strange from what's typical. And right on cue, the Vera C. Rubin Observatory has officially joined the hunt. In July 2025, it released its first light image, marking the start of full science operations. For the next decade, Rubin will scan the southern sky every few nights, catching supernovae, asteroids, and yes, more interstellar visitors. It's the best shot we've ever had at catching the next one before it slips past. If Oumuamua is a fragment of frozen water laced with trapped hydrogen, it may have wandered the galaxy for hundreds of millions of years, knocked free from an Oort cloud around some long-forgotten star. If AVI-Lub is right and the object is engineered, then the implications are staggering. It would be proof that someone else mastered interstellar travel before we invented powered flight. This would mean Earth has already been noticed and a second, more capable craft could follow centuries or millennia later. Or maybe the civilization moved on, unimpressed by what they saw. We will never know. For now, statistics favor a natural origin. Yet, until a mission samples the surface or Rubin uncovers a fleet of similar shards, we cannot lock the case. That's all for today. I hope you enjoyed the video. Let me know your thoughts by dropping a comment and don't forget to